So first up, before we understand equations, we need to understand what a solution is. And in fact, the difference between an equation and an expression is simply an equal sign, okay? So last lesson we learned about expressions. Now we are learning about equations, which is really just two expressions that are made to be equal to each other. Now when you see an equal sign, sometimes we think that it just has to be a true statement. It doesn't. Sometimes you may see 1 equals 2. Now, this is a statement. Equal signs are still questions, okay? So when you see an equal sign, you still have to ask yourself, is that a true statement? The statement that I've made here, 1 equals 2, is a false statement. And therefore, we would just declare this as false. But I can make it very quickly. I can make this true by simply saying 1 plus 1 equals 2. Now it is true. Okay, so you need to remember that equal signs are still questions. This would still be a question. Does 1 plus 1 equal 2? And the answer is yes, it does. Okay, now in the future, including today, we're going to see that instead of seeing a 1 there, we may see an X right there. From what we just barely saw, though, we should hopefully understand that the value that I need to replace X with to make this true would be 1. Now we usually show it like this, X equals 1. And then we would even box this in saying that is the value of X that would make this a true statement. So therefore we would consider that our solution. So a solution to an equation is a value that you replace the letter with, or variable, that will make the equal statement a true statement. So when it says solve for X, or if it says solve, it's really saying, it's really asking what value of X makes the equation a true statement. And again, in this case, it would be 1, okay? Okay, one last note about solutions here is you can see right in this equation, if I replace X with 1, it is a true statement. There are an infinite number of values you could replace X with to make it a false statement. So be careful, because there's an infinite possibility of getting this wrong or making it false. We want to make sure that we are making true statements with the numbers that we're replacing the letters with. Now we're going to go over rules on how to solve equations, which is part of our objective. But first, we can look at something like this, and we can say, well, what number would I replace X with here to make this a true statement? And I know if I replace X with 10, then I would get a true statement, because then it would show 10 equals 10. Which, last time I checked, is true. Now be careful, there's people out there that would say that 9 equals 10, and that's good enough. It's just that it's a false statement, okay? So right here, we would even write the solution as X equals 10. So if you replace X with 10, then you get a true statement, and so we would say, well, I have my solution. Now this one may be more obvious than it needs to be. But again, I just need you to understand what a solution is. So when we look at an equation like this one, so something plus 2 equals 10. Now again, I'm avoiding the rules right now. And I think some of you could do this in your head. If you can't, don't worry about it. We'll go over the rules. But the value that I would have to replace X with right here would be 8. So we would write the solution, X equals 8. I can even check. So up here, I would say, well, what happens if I replace X with 8? Well, 8 plus 2 does equal 10. We can even put a question mark over there. That would be a true statement. And then I know for sure that if I replace X with 8, here I have a true statement. So X equals 8 is actually the solution to that equation, all right? So it's important to understand, again, that there are an infinite number of values you could have replaced X with to make it false. You could replace it with 10. That would make it false. If you replace it with -5, still false. Even if you replaced it with -10, still false. Or even any decimal values would make that false. The only value that will make that true is X equals 8. Well, what if we see subtraction in the problem? Still, it shouldn't be a problem here, right? So something -4 needs to equal 10. That's something right here. And this may take some thought right now while we don't have the rules, but I know if I replaced X with 14, I will then get a true statement, because 14 minus 4 does actually equal 10. And then I know that X there equals 14. That's my solution. Now again, the questions on the assignment, they may not ask you for the solution. They may say solve for x. It still means the same thing. What is the solution to the equation? You have to find a value that makes it a true statement. So here's another one. In fact, let's zoom in a little bit. So 5x equals 10. 5 times something equals 10. Now, some of you may even be saying, well, there's no multiplication sign there. Multiplication is the only operation which we do not always have to show. Sometimes we have to show it, but not in this case. That means that if you want to see it, you can put the multiplication symbol between the 5 and the x if that makes you feel good about it. But you do not have to. So on this one, we got 5x equals 10. What we really want, though, is to know what value of x will make this a true statement. And I know if I were to take that x and replace it with 2, then I should get a true statement, right? Let's check. 5 times 2 is 10. Yep, 10 equals 10. Boom. It's a true statement. So now I know x equals 2. That's my solution. So I've seen those 3 operations: addition, subtraction, multiplication, now division, right? Something divided by 2, it needs to equal 10. And again, this may take some thought. Something divided by 2, what would that something be? Is 20. So if you were to replace x with 20 here, then we would have 20 divided by 2. 20 divided by 2 is 10. That's on the left side. 10 equals 10. That would be our final equation there, and that is a true statement. So now I know x equals 20. That's my solution. So some of these you may even see. You don't need to show any work. You could just possibly do it in your head like we did these ones. All right. But again, we have rules that will help us to solve these if by chance we can't do it in our head. Now, I still recommend kind of using these all the time, but you don't have to, because sometimes it may be easier for you not to, and that's okay. So right here, no rules. The rules are the objective.